Hi, in this video we are going to discuss about the locality sensitive hashing. In the previous video we have discussed about the KD tree. KD tree approach we have some disadvantage. One of the disadvantage time complexity problem is there in KNN. To solve that problem we are using the KD tree approach. And another approach we have is the locality sensitive hashing. By the name of the name we can tell that we are going to use the hashing approach and we are apply the localize the data points. Localize means we are going to group. Let's see how is it going to work. For suppose we have data points like this, let's consider, and let's call this data points x1, x2, x3, so on like this. And we also have a hash function, hash table, and we have hash function h of x. Okay, hash table contain a key and a value. We will give a point to the hash function, we will get a key, and with that key we store that value. Okay, x, like that. Now how we can get these things? Here we are apply the hashing and localization. Here hashing means that we give this point to the hash function that we have. From the hash function we will get a key. That key is this one, and then the point will be stored here. Similarly, there is a possibility to get the same key value. Okay, for this let's consider this is a group. For this group we are going to get the same key value for x of 1 and x of x, h of x2, h of x3. Let's consider we have up to 10 points are there in this group, h of x10. For this all the hash function values we will get the same key. Okay, let's consider k dash, and here we have 10 points are there, and 10 points will be stored in the same, for the same key x1, x2, x3, x10. Okay, x10 10 points are there. When a new query point came, let's suppose a query point xq k here, this was located here. For this query point also we will get same key, this key we will get, and here we will going to find the distance from this query point to these 10 points. By this way, instead of finding the distance from all the points in the data, okay, we are going to only find the distance in this group, and that means this box. This is the main thing, and here we have two approaches how we can make this group. Based on that, we have cosine similarity approach is one technique is there, and randomized approach. In the in the cosine similarity approach, let's consider 2D space, and here x1, x2, x3 is the 3 points, and finding the cosine similarity we need the theta values, that means angle between the points. We are going to find here we can see theta 1 2 is the angle between x1 and x2, and theta 1 3 is the angle between x1 and x3. Here theta 1 2 is going to be very close. Theta is very close to 0. That means we can consider this point as similar bucket. Okay, the theta 1 3 is not equal to 0, it's very far, those points. By this way we can get the same key value, and we are going to get the x1 and x2 in the same bucket, and x3 we will get different key value, and we will store those key value this x3 in the different bucket. This is the by using the cosine similarity approach. Let's see the randomized approach. Let's say locality sensitive hashing using the random planes. For this, let's consider some data points in the 2D space. These are the data points, and here we are going to create some random planes. By this way, we will get the hash function values. We create the hash function keys, and with that keys, we are going to get the points, grouped points. We'll group the points. For suppose, let's start creating some random planes here. Let's this one. I will use this color. This is the one plane, let's consider. This is the another plane, let's consider. And it might be other plane, let's consider. I think it's good. And let's consider 4 planes as of now. Here also. Yes. Now this one, let's consider pi1 is the plane and the vector represent using w1. Here it also pi2 and the vector representation w2. This one also pi3 and vector represented with the w3. This one also pi4 and vector represented with w4. Now here, because of here we created the random 4 planes, so we will get by hashing the every point, we will get the 4-dimensional point. 4-dimensional point. Okay, because it is a 4 planes, we will get 4-dimensional plane. If it is 5-dimensional, 5 planes will be there. We will get the 5-dimensional key value. And this values contain signs of these points. How we will get that signs? Is basically this. Let's consider this one is related to pi1. This is related to pi2, pi3, pi4. Here, the sign means positive or negative. Sign of w1 transpose x1. Suppose let's consider this point is x1, and we are going to find this hash function key. That means by applying the x1 to the hash function, we will get this one. And here sign of w2 x1 w transpose. Here sign of w3 transpose x1. Here sign of w4 transpose x1. Let's see what are the values that we will get here. This is the point and the sign. For the let's start with the pi1. This is the same direction to the x1. By this way, we will get the positive. That means this vector direction and the point direction will be same direction. And for pi2, this is a pi2 direction and the point direction also in the same direction. By this way, we will get positive sign here. Let's see pi3 and the x and also is the same direction. We will get positive sign here. And pi4, that means vector w4 and x1 is in opposite direction. This was in direction, but this point is opposite to this direction. By this way, we will get negative. Let us consider one more point. Let's consider x2. Let's consider this one as x2. Here I can see for the x1, it is the opposite direction. This one direction. This is opposite to the w1. By this way, negative. And then pi2 also it is the opposite direction. Then negative. And pi3 it is the same direction. This is the point vector direction. This point also is the same direction. By this way, positive. Here w4 is also same direction. By this way, positive. By mapping this like this. For suppose this is the hash table. Okay, with this key we are going to get we will make a group. These all the points, these all the points going to bet here only with this hash key value, and these are the points that we will get here. Okay, similarly a query point came, a new query point came at the time also. Suppose here, and here also we will get a change signs. That means here we will get negative, negative, positive, positive we will get. By this way we have some group of points will be stored here. Okay, we will find the distance from the all the points which are located here. For suppose these are the points located there, we are only going to find the distance from this query point to these points only. Not we are not going to find the distance from these points and these points. By this way we are going to save a lot of time here. This is the another approach.